In previous lectures, we installed Truffle and Ganache that can easily emulate an Ethereum node for development purposes. While these fake Ethereum nodes are an easy way to test your application, you have to keep in mind that they are just emulators. They provide the same interface as an Ethereum node deployed in the public Ethereum network, but internally they work completely differently. If you want to ensure that your contract will run properly on the main network, it is highly recommended to test it with a full Ethereum node. In this lecture, we'll install a private Ethereum instance with Geth on macOS. If you are on Linux or Windows, there are dedicated videos for those environments. Let's start by creating the folder that will host the database and the accounts for the private node. So we open a terminal, and to create those directories, we are going to use mkdir -p to create all the parent directories. Tilde is for the user directory, for the home directory, and then we put that in chain skills/private. And then we can go there. Okay, so with these commands, the tilde character represents the user home directory. So here my username is sarbogast, and if I do a pwd to print the working directory, I am in the private directory. Now, before creating our private instance, we have to define the genesis block. That is, the block that will define the initial behavior of our blockchain instance. Creating a genesis block file from scratch can be painful, and reusing an existing one can be a problem if its version is older than your current installation of Geth. To ensure that your genesis block file is compliant with your version of Geth, we'll create it using a tool called Puppet. Puppet is a command line tool that's installed with Geth, and that provides features to create and monitor your own Ethereum network. So now let's use that tool to create the genesis block file. So of course, you have to do that from the private directory, and then you can run Puppet. So first we have to specify a network name for our private network. We'll call it chain skills. Now we can use one of those commands, and here we'll use command number 2 to configure a new genesis. Our private Ethereum node will use a proof of work consensus algorithm. So let's choose option 1 for Ethash. And we do not want to define an account to be pre-funded, so we just type enter on this. Then we have to define a network identifier for our private node. This identifier must be different from those that are used for public networks. So number 1 is for the mainnet. Number 2 is for the modern test network. That is now obsolete. Number 3 is for Robston test network. Number 4 is for Rinkeby, and we will use that later. And number 14.2 is for the Kovan test network. In our course, we will use the network identifier 4224. 4224. So here we have the option to add some custom text to the genesis block. We won't do that, so we just type enter. So now we created this genesis block. We just need to export it, and to do that we need to choose option 2 in this menu to manage existing genesis. And here option 2 again to export the genesis configuration. By default, it will save it in a chainskills.json file and will accept the default. And that's it. As you can see, we have this line that says exported existing genesis block. Now you can press Ctrl C on your keyboard to exit this tool. And if you list the content of that directory, you will see the chainskills.json file. And we can open it in Atom now that we installed it. So here are the most interesting items in this Genesis file. Config is a section that is used to define parameters for the chain. The network ID used for this instance is specified in chain ID. And config also contains the block numbers from which to apply various hard fork rules that have been added to the Ethereum chain over time. For example, in our case, the Byzantium rules will be applied started from block 4 in our private network. Then timestamp is used by the Ethereum virtual machine to adjust the level of difficulty that must be applied. If the timestamp difference between two consecutive blocks is too small, the difficulty will be increased. If the timestamp difference between two consecutive blocks is too high, the difficulty will be reduced. The timestamp is also used to ensure that blocks are in the right order. Then extra data can store any information that we want to label our blockchain instance. Here we didn't set anything. Gas limit defines the maximum value of total gas transactions in a block can spend. This value is here to limit the processing requirements of each block and in effect limits the size of blocks. In a private node, you can set this value to the maximum while keeping in mind that you have to measure the gas spent by your transactions. Difficulty defines the difficulty level that will be used to validate a block, which directly correlates to the average number of times a miner will have to run the hashing function to solve a consensus puzzle. On a private blockchain instance, it is recommended to set a lower value for this field to reduce computation time. Then Coinbase is the address that will receive all the mining rewards collected after successful mining of this Genesis block. And this value is superseded by the address of the miner when a new block is created. Alloc is a section where we can pre-allocate funds to some wallet addresses, and here we didn't do that. And at the very end of the file, after the alloc section, we can also find number, which is the block number, and in that case, since it's a Genesis block, the block number is 0. Gas used is the total sum of all the gas used in this block. And parent hash is the hash of the parent block. And since we are in a Genesis block, it doesn't have any parent, so this hash is 0. Now that we have our Genesis file, let's use it to initialize our private node. Let's quit Atom. Now, the private node will be created using the geth command with the following parameter. We need to specify the data directory, which is used to set the target directory where the private node data will be saved. Without this parameter, the node would use the folder of the main public node, which is not what we want. And we'll also use the init command to specify the Genesis block to initialize the private node. Again, in this command, the tilde character stands for your user home directory. So let's clean up our terminal and run the following command, again from within the private directory, geth --data dir, and this will be the chain skills / private directory within my user directory, and then init, and we can specify chainlist.json since we are chainskills.json since we are in the directory where this file is saved. So again, geth --data dir with the path to store the chain data, and then init and the file. So we run that command, and that's it. So at this stage, you should see two directories inside the private directory. Before we just had the chainskills.json file, and now we also have the geth and the key store directory. Geth will store the blockchain instance data, and key store will store all our accounts. So if we just list the content of key store, we don't have anything. At this stage, we only initialized our private instance, but we also need to prepare it for mining and for usage. The first thing to do for that is to create a couple of accounts. In our case, we'll create 3 accounts that we will use later in this course. The first one will receive mining rewards, and the other 2 accounts will act as the buyer and or the seller of the articles in the chainlist app that we will build later. To create those accounts, we use the geth command and specify the path of our private node, so the data directory, and also the account new command. For testing purposes, we use the same password for all accounts, that will be pass1234. If you choose another password, please do not forget it, otherwise you will not be able to unlock the accounts and your fake ether will be lost. So again, make sure that you are inside the private directory. And here we can do geth dash datadir dot to say the current directory and account new. Now we have to specify the password twice. So again, we'll use PASS1234 and we specify it again. And that's it. We just created a first account. Of course, the address on your environment will be different. We run that command a second time. We get a second account and we do it a third time. And now we have our 3 accounts. They are created and they have a unique address. Of course, these addresses will be different for you as they are randomly generated. And the private keys of these accounts are located under the key store directory. So now if I list the content of the key store directory again, I find 3 files that each correspond to the private key of one of those accounts. And another thing that's important is that each account can be identified by its position in the array of accounts registered on the node. To list these accounts in order, you can use the following geth command with the account list parameter. So geth dash datadir again dot account list. And here we get account 0, account 1, account 2 with the corresponding wallet address, and where the file, the corresponding file is stored. So far, we initialized our private node and we created 3 accounts for it. But it didn't start yet. In order to start our private node and mine blocks, we will create a script that will define all the required parameters to let us interact with our private node. On a macOS environment, we will create a startnode.sh script that I'm going to show you in a moment. Just remember that this script is attached as a resource to this lecture, so you can download it and use it directly. I'm just going to go over it now to show you what the different parameters are and what they are used for. It's very important, by the way, that all this command line is just on one line in your file, that there is no carriage return or line feed, because otherwise some parameters will be ignored. So let's create our start node file, startnode.sh. And of course, it starts with the geth command. And we need first to specify the network ID, which in our case is 4224. We need to activate mining to make sure that this node starts mining right away. But we can specify how many threads we want the miner to use. And in our case, we'll use miner threads 1 to say that it should only use 1 thread. If you have a more powerful machine and you want to mine faster, you can increase that number. Dash datadir is used to specify the directory in which we will save the data for the chain. Again, tilde is for the user home directory. Then we want this private node to be isolated, not to look for peers and connect to other nodes. So we will deactivate the discovery protocol. And to do that, no discover. Then we want to enable the RPC endpoint because we want to connect to our node over RPC. That will be useful for MetaMask, for example. So --RPC. We can also specify the RPC port, --RPC port. And the default one is 8545, and that's the one we will still use for the private node. Since we're here, and even though the discovery protocol is deactivated, we can also specify the discovery port. That will be --port, and the default is 30303. We want to be able to connect to our node from any domain, so RPC course domain with a star. --nat has to do with the network configuration, so you just need to specify any in double quotes for that. And then we need to enable a certain number of modules for the RPC endpoint, and this is done with RPC API. And then we can list all the modules that we want enabled. So, of course, we want ETH, Web3, so you separate all the modules with a comma. Personal will be useful as well, and net. Also, since we are going to use the first account as a mining reward recipient, we'll unlock it. So -- unlock, followed by the index of the account to unlock, which is 0 in our case. And we want to specify the password for this account so that the get command is able to unlock it. So -- password, and then we specify the path of the file that will contain the password. Gene skills / private / password, password.sec. And we will create this file in a minute. And the last parameter is probably one of the most important, and one of those that has the biggest consequences is the IPC path. So when you start a node, it will create an IPC endpoint in the form of a file. It's like a log file if you want. And then other tools like the Geth console or certain dApp browsers and so on will want to connect to the running node and will look for a specific IPC path in a default location. So if we just start the node without specifying IPC path, it will create the IPC file in the same directory. So in our case, in the private directory. What we want is to force Geth to create this IPC endpoint in the default location where other tools are going to look for it. And on macOS, because it varies depending on the operating system, but on macOS, it will be in in your user directory under /library /Ethereum /geth.ipc. And this is very important because then we will use Geth to attach a console to our running node, and Geth attach will by default look for this file in this location. So if it doesn't start in the right location, we'll have an issue. One thing that is very important is that you make sure that this entire command fits on one line and doesn't contain any line feed or carriage returns. Otherwise, everything beyond the first line will be ignored and you will have issues with your configuration. So here it's on one line and we can save it. Before we can run this script, we have to create the password.sec file that will store the password for the first account. So from Adam, I will just create a new file in the private directory by right-clicking private, new file, and then I can call it password.sec. And here I can just type pass1234, which is the password I chose for all three accounts that I created on my private node. And I save. Again, if you're not sure about the content of startnode.sh, remember that this file is attached to this lesson as a resource, so you can just download the startnode script and run it as it is. The last thing we need to do before we can execute it is to make it executable. And to do that, I'm going to use chmod +x startnode.sh. If you forget this step, you will get a permission denied when you try to run the script. And now we can start our private node. So let's go full screen first. I'm going to quit Atom. Show a bigger window. Clear it a little bit. And then I can run startnode.sh. I will quit it right away just to show you the beginning of the logs because there are a few very important pieces of information in there. Okay, so we start a peer-to-peer node and here we can see the version for Geth that is used. Here we can see that the chain configuration uses our 4224 chain ID, as well as all the value that were configured in the Genesis block. Another very important piece of information is this line. So we can see that the IPC endpoint was opened in the library/Ethereum directory under my user home directory. If you have something different here, I mean, if it's not in library Ethereum under your user home directory, you will have an issue later. So you need to fix that first. If you see, for example, that get.ipc is created in your private directory, you have a problem. That means there's something wrong with your start node script. So make sure this is correct. We can see that the HTTP endpoint was opened on port 8545 as well. And we see that the first account was unlocked successfully. And of course, there's one thing I forgot to show you is that the database for the node is stored under our data directory as instructed. So here, all the data files will be saved under geth/chain data inside our private directory. So after all this configuration output is there, you can see a series of lines that starts with generating DAG in progress. Now the DAG, or directed acyclic graph, is a data structure that is needed by the Ethash mining algorithm to do its work. It is generated once every 30,000 blocks and stored in a file under .ethash in your user directory, which you can see, by the way, here. Disk storage enabled for Ethash DAGs under your user directory in the .ethash. Now we'll leave it running because generating this DAG the first time is going to take a little bit of time. And you can follow the process by looking at the percentage here. So here I'm on a rather powerful laptop, so it goes pretty fast, but it can take a few minutes. So it will do it a first time for epoch 0. So an epoch is a period containing 30,000 blocks. So it will do it for epoch 0. Then when it's done, it will start doing it for epoch 1. And when it's done for epoch 1, your your node will start mining. So here you can see that it stopped. It reached 100% for epoch 0, and it started doing it for epoch 1. And at the same time, it started mining. So every time you see a line with a tool like that, with a hammer, or something that looks like a hammer, it's actually because it's mined a block. Now you're better off waiting for the DAG to be completely generated before you can use the node. So every time you can see a line with a pickaxe, I think that's the name of the tool, it means that it's mining a block. And we're almost done with epoch 1, and that's it. Now the node is ready and it will start just mining blocks. Now, if Geth seems to be stuck for several hours on one of these steps, it might mean that you forgot to initialize your node with the Genesis file, or you forgot to create some accounts. Or there is a mistake in your startnode.sh, or your chain data is corrupted for some reason. So your best option is just to delete the private directory altogether and to do the whole procedure again. Don't forget that you can download the startnode.sh script from the resources attached to this lecture to be sure that there is no mistake in it. And if after all that your private node doesn't start mining as it should, feel free to copy-paste as much of your startnodes.sh console output into a question in the Q&A section of this course, along with the content of your startnode.sh script, and we will help you troubleshoot what's going on. At this stage, there's just one thing that you might be concerned about, is why is this node mining when it doesn't contain any transaction? It's isolated, I'm not sending any transaction to it, and yet it's creating blocks. You have to remember that the sole purpose of mining is not just to mine transactions. It is also to generate new ether. So with a normal proof of work algorithm, consensus algorithm, like the one that we've enabled on this private network, we are actually generating new blocks at regular intervals of time, whether there are pending transactions or not. And each of these blocks creates a new quantity of Ether that is assigned to the miner. And in our case, that's the Coinbase account, the first account that we created. Okay, so don't be worried if you see blocks generated, even though there are no transactions. This happens with every single instance that uses a proof of work algorithm. Even on the mainnet, so on the public network, we have blocks that don't contain any transaction. Okay, so now our node is mining, so we can try and connect to it from outside. So we can open a new terminal. On macOS, we can just open a new tab. And from there, we can run get attach command. And the get attach command will look for the IPC endpoint in the default location. And that is, again, under library/Ethereum in my user directory. And here it found it, so it was able to connect to my running node, which I can confirm because it's the right version of Geth, of course. The address of the Coinbase account is the one I created earlier in this lesson. The data directory is okay. That's chainskill/private. So always when you start Geth attach, check that the data dir and Coinbase match the ones that we defined before. Otherwise, it means that Geth console attached to another running node, which by the way, you should try to avoid. So if you already have Mist or Ethereum wallet or another instance of Geth running on the mainnet, for example, you cannot start your private node at the same time because they use the same RPC port, which is 8545. So always remember to keep your running nodes clean. We'll see later that with Ganache, we don't have this problem because it's running on a different port, but your private node will be running on the same port as the mainnet if you're starting Geth or Mist on the mainnet. So if you get an error like unable to attach to remote Geth, because Geth IPC, there is no such file or directory. Again, that means that the IPC endpoint was opened in the wrong directory. So you have to check the console output for the start nodes .sh at the beginning and make sure that the IPC endpoint was opened in the right location. Now, what's interesting is that within this JavaScript console, because Geth attach is a JavaScript console, as you can see here, we can type some commands that are exposed through one of the APIs defined in the RPC API input parameter. So we can see a list of modules that we have access to at the beginning of our console output. And what's important to note is that we can also attach to a node using not the IPC endpoint, but the RPC endpoint with an R. And if we do that, there are some APIs, some modules that we won't have access to. But with the IPC endpoint, we should have access to everything. Now, here are some of the useful commands that we can use within this console. So, for example, we can type eth.accounts, and we get a list of the accounts that were created and registered on that node. And here we can see the first one, the Coinbase one that is used for mining rewards. We can also, by the way, use the Coinbase command to get just this account. By the way, what I mean by Coinbase here is really the concept of the main address that is used for mining rewards. The Coinbase.com website that you might know is actually named after this concept, not the other way around. Another command that we can use is getBalance. So eth.getBalance to get the balance of an account. And here, for example, we can get the balance of accounts 1. And this one has 0. But if I do the same thing for account 0, the one that is receiving mining rewards already, we can see that we have some Ether there. Actually, getBalance returns a number of Wei. Wei is the minimum unit of value on Ether, so it's 10 to the minus 18 Ether. And there's a command in the Web3 module, it's called fromWei, that we can use to convert from Wei to Ether. So eth.getBalance for the eth.coinbase account, for example, and we can specify the unit that we want to convert it to, Ether, and that's it. So we see that the account already has 81 Ether in it. We can also use miner.stop to stop the mining process. Now if I go back to the tab where I have my node running, the mining has stopped. And if I go back, I can also restart the miner with miner.start, and I can even specify the number of threads that I want to use to mine. So here, the mining process started again, starting mining operations, and it started mining on 2 threads. Now, of course, if I just use the command without specifying anything, it will use the default as configured. Another command I can use is net.version, and this will give me the network identifier, 4224. And last but not least, I can use the personal module to manage my accounts, and more specifically, to unlock them. So let's say I want to unlock account 1. I can do it with personal.unlockAccount, eth.accounts1. Then I need to specify the password. And then the time frame during which I want to unlock this account. So for example, if I want to unlock it for 5 minutes or 300 seconds, I can indicate 300. Now, if you wonder what unlocking an account means, it means that, well, basically your private key for your account is always protected with a password. When you type this password and you unlock this account, you basically make the private key available for signing transactions. While an account is not unlocked, you cannot use it to send transaction, and you will get exception saying authentication needed. You need to type your password to unlock the account. And if you just type personal.unlockAccount and specify just the name of the account. So for example, if we want to unlock account number 2, then it will ask for the passphrase. And I think the default time frame is 10 minutes. Oops. So this is because I made a mistake in the passphrase. So I need to do it again. Now unlock account eth.accounts2, and then that's this. And when you see true, it means the account is unlocked. Now you can find a comprehensive list of commands on this link that I'm displaying right now. And again, this link will also be in the resources of this lecture. Now, let's use this get console to send some Ether between accounts. So we'll transfer some Ether from the Coinbase account, the one that is currently mining, to the other 2 accounts. So again, eth.accounts lists all the accounts, and eth.coinbase corresponds to the account that's receiving mining rewards. And we also have the balance of the Coinbase account that is now 273 Ether. So to send cryptocurrency between accounts, we use the eth.sendTransaction function. Here we will transfer 10 Ethers from the Coinbase account to the 2 other accounts. And then we'll check their balance. To do that, we can use eth.sendTransaction. And here we specify all the parameters in a JavaScript object. From will be the sending address, eth.coinbase. To will be the receiving account, so eth.accounts1, for example. And then value will be the number of way that we want to send from one account to the other. And for that, we can also use the web3.toWay function before we use the web3.fromWay to convert from Way to Ether. And here we need to do the opposite. So here we want to convert 10 Ether into Way. And we need to end this call to toWay. When I send this command, I get this weird string that is actually the hash of the transaction that was created to send the amount. And if I go to the tab that's running the node, I can see that a transaction was submitted, and there is the hash of this transaction, B695, which we can find here, B695. Okay, I can run this function again to send value this time to the second account. And I get another transactions. And by the way, you can see that this transaction was already mined into a block. So thanks to that, if we run fromWay on eth.getBalance for eth.accounts1, for example, this time it contains 10 Ether. And I can do the same thing for account 2. And for account 0, well, you won't actually see the difference because it kept mining in the background. Again, this works because our node is mining in permanence. So whenever we send a transaction to it, it's mining it into a block pretty much instantly. But if mining was stopped, then the balances would not be updated. At any point in a getAttach console, you can always quit by typing the exit command. Okay, and now we are back in the terminal. Now, if you want to stop the private node while it's running, you can just type Ctrl-C on your keyboard, and you will see got interrupt shutting down, and HTTP endpoint closed, IPC endpoint closed, and everything is stopped. So, in this lecture, we explained how to create a Genesis block file with Puppet. We initialized a private node with a Genesis block. We created 3 accounts. We started the private node. We attached a console. We checked the list of accounts and their balances. We started and stopped the mining process, and we sent Ether from one account to the others. Note that you can find the Genesis file and the startnode.sh script that is attached to this lesson as a resource. In the next lecture, we'll show you how to install MetaMask in the Chrome browser.